Welcome to the Ventec stand here at Productronica. Delighted to be joined by Mark Goodwin, who's the COO of the company. Nice to meet you, Mark.
Yeah, hi. Yeah.
So you've got a huge range of different laminates and substrates that you sell to the market, basically, or the various markets, should I say. But that creates a lot of confusion, really trying to mine down to which is the best choice of substrate for the application.
Yeah.
And you've gone some way to try and make this easier for people by introducing a new series called Autolam.
Yeah, in fact, Autolam's the first of a number of things we're going to do, specifically directed at the automotive sector, which is actually a very broad sector now. Everything from lighting, LED lighting, cabin lighting, ECU, electronic power steering, onboard charging, fast charging, so many different applications. And the idea was to almost curate a set of materials to meet the needs of each of these individual applications within the automotive sector. And we plan to do this for our other key market sectors as well.
Okay, well, that makes a lot of sense. So let's go through some of the options you've got here in this brochure in front of me. You're talking about, obviously, the thermal management systems that you're using around the LED structures, for lighting and different things like that. What are the alternatives you're offering there?
Thermal management is a very wide area. Started for us in the LED lighting, LED front lighting, high power front lighting. This is typically a heat sink material with a thermally conductive and electrically insulating dielectric and a copper foil to carry the circuit pattern and we've developed materials, anything from standard materials, which are sort of 2.2 watt per Kelvin meter, right up to 7 watt and above. But that's just thermal conductivity. What people are interested in is reduced thermal impedance. So you want to make those materials as thin as possible as well. So we have high thermal conductivity and materials down to 50 microns of thickness. And then, of course, you have people will start to worry about electrical breakdown and high pot failure, and depending on what you're building, on the voltage of the system you're building, you can vary the thermal conductivity and the dielectric thickness to provide an optimized material for your application.
I mean, the automotive industry is going through quite a change at the moment. We don't really know where it's going to fall, but there is some argument around the high voltage powertrains, which are coming in at 24 volt, and the low voltage materials that are getting used for the instrumentation and that type of thing. Are you involved in providing substrates in the powertrain end of this?
Particularly powertrain. Powertrain, again, I think there's a place for what we call IMS, insulated metal substrates. Yeah, we have many discussions on powertrain about that. There's people even building things like electronic turbo type systems that have to get rid of a lot of heat quite quickly, and looking at that. Power electronics generally leads you to a thicker dielectric for electrical breakdown purposes, which also pushes you up the requirements for thermal conductivity, because as you make the material thicker, you need the higher thermal conductivity to compensate for the increased dielectric thickness.
Right. Yeah. I mean, I think that's going to be an increasing trend for you generally as a laminate manufacturer, because it's not just happening in power electronics. You've got all this 5G coming down the pipe, which is going to have the same thing.
5G we have a completely different set of materials for, but in power electronics is driven really by thermal management. Yeah.
So let's look again back at the Autolam series. What other things are we looking at beyond the thermal management?
It covers a very diverse range. We've already touched on 5G, so we've got our hydrocarbon materials in there, which are sort of materials for our antenna type applications. We've even made mention of a new product we were about to launch, which is TechSpeed 30, which is PTFE. This is in the collision avoidance, high frequency radar type fields. But we've also got relatively standard materials in there. FR4, or more, I should be more correct and say FR4.1 or FR15.1 with MOT 150 for underhood applications, right. ECUs, this kind of thing. So we've done the long-term thermal aging work with UL to get our materials qualified as FR15 or FR15.1. Right. In fact, to be fair, we stuck only with FR15.1 halogen-free because we can do it with these materials. We don't want to complicate the offering further by having both a brominated and a non-brominated offering in this space.
Right, excellent. So the FR15 is UL certified, but you've also done it now though. You've taken the long term to do the FR4 as well, in 4.1.
Well, yeah. So yeah, what happens is they're actually the same. They're the same material, but they're tested again to a different level of long-term thermal aging reliability. It's reliability against long-term use at higher temperatures for long-term.
Okay, great. So what other sections do we have in here that we the power steering, obviously?
A lot of IMS used in power steering as well.
IMS
We're
materials.
still in IMS.
Mm-hmm.
What have we got in infotainment, electronic control units? This is the FR15.1.
Mm-hmm.
But infotainment, we've got requirements, for more standard FR4s, but also high-speed, low-loss materials. So we've got our tech speed range of materials in there, which is a range of materials.
Is that for the infotainment?
It can be. I mean, the car's becoming almost a server on wheels now. I mean, it's got communication, it's got to deliver information quickly. So it's high speed, low loss. Everything now is in a car.
Right.
This is why I think we start to see companies from other markets getting very involved in the e-vehicle. We've got autonomous driving coming. All these kind of things require high-speed data rates, signal integrity, as well as communication, which leads us into the hydrocarbon and the antenna materials.
Mm-hmm, mm-hmm. Excellent. Yeah. Well, as we said earlier before we started, the automotive industry is at a crossroads. It's not really settled on which technology it's going to be going forward with, but it sounds like you're fully covered for whichever technology.
It can go in a number of directions,
Yeah.
and we can cover a number of directions. I think the industry now needs a bit of input from government strategy now, and because what's holding back e-vehicles? A bit of infrastructure. People don't know whether they're going to be taxed on their diesel car or whether they're going to be taxed on their electric vehicle. Nobody knows what's going on. So government needs to sort this out. I think the industry is at a crossroads, but the next 1 to 2 years are going to be very interesting, and it all means more electronics. Whatever comes, it's more electronics.
Absolutely, I couldn't agree more. But so, anyway, Mark, nice to see that you're prepared for all this. I think your Autolam brochure is a great idea, and thank you for telling us about it today.
You're very welcome.